So, see, okay, let me explain the chemical bond. Chemical bond. Do you know what is the chemical bond? That is, chemical
Yes.
bond is the force of attraction. Simple term is the force of attraction between atoms which holds the molecule together. That is what the chemical bond. Got it? Now,
Oh,
if I will ask you types of chemical bond, types of chemical bond. Can you tell me chemical types of chemical bond? Basically, you are having the three types. That is
oh,
covalent, uh,
ionic.
ionic, and that is coordinate.
Oh,
Okay.
okay, sir.
These are the three type are there. Uh, Here the problem they ask in these two, covalent and ionic bond, they ask the problem, right? Because here
Oh,
you need to study the Fajan rule. Have you heard about this one, Fajan rule? Have you heard this
no,
one, Fajan rule? Fajan rule is for the, okay, I will tell you. First of all, can you tell me what is the covalent bond? What do you mean by covalent bond? What do you mean by covalent bond?
covalent bond is bond between uh, like it's not like ionic bonds. They it occurs when two species when they share the electrons.
Okay. That is the co means equal. Here, if I will write co means equal. Okay. And valent, if I will write valent means sharing. This is the total pad is not.
So that Fazan rule is for
Pajan's rule is for the explanation of ionic character in covalent bond or the covalent character in ionic bond. Both applied. Means Fajan rule said no bond, no covalent bond is 100% covalent and no ionic bond is 100% ionic. Each
mm,
ionic bond must have some amount of covalent character or each covalent bond must have some amount of the ionic character. So this is what.
mm,
There are four
okay.
points are there that I will tell you. Don't worry. Firstly, let us go in the basic. So covalent, if I will ask you the covalent, if I will ask that is covalent. So that is the if two atom is there, suppose H2 is there. So here is co mean equal and valence mean sharing. So equal number of sharing of electron. Suppose you are having the hydrogen. So hydrogen, one hydrogen, if we go, that is one electron is there now. 1s.
Ah, yes, sir.
1s1. Another hydrogen, if you see, this is again going to be 1s1. So what is going to happen here? That is hydrogen atom, another hydrogen atom, one electron they are taking, and then what they are making? They are making the shared their one electron, then they form duplet. Here is two electron, this is two electron. Duplet, you do you know what do you mean by duplet?
Yes, sir. Duplet configuration.
Duplet configuration. That is called noble gas configuration, like
Ah,
helium, neon, argon, krypton, or the xenon,
xenon.
or you can say radon. These all the elements are having a noble gas configuration. Noble gas configuration means stable configuration. This is two electron.
Ah,
Two electron means that is s orbital is fully filled. So that is stable
hmm.
configuration. Here is the octet will be there. 8 electron will be there valence shell. Here is 8 electron will be there. So they completed the octet. So here you see one electron here now. So if you count that is each is having the two electron in their circle. And since one
Hmm.
electron here, so that is got single bond. This is what is called single covalent bond. This is called single covalent bond. Is it okay?
Ah, okay, sir.
Huh. If suppose if anybody is asking what is double covalent bond, so double covalent bond means two electrons here. Suppose O2 is there now, O2. So what you will find, oxygen is 8, another oxygen is 8, configuration is 2 comma 6, 2 comma 6. How it can be that is the stable? It can be stable only when they gain two electrons, right? But both are having same electronegativity. So nobody is going to give the electron. What they can do? If they are having equal strength, both are equally attracting. Equally attracting means what? They are going to form the covalent bond. Are you getting this?
Hmm.
So
Ah,
because both are having same electronegativity. So here you see oxygen 1, 2, 3, 4, 5, 6. Another one 1, 2, 3, 4, 5, 6. Now what is going to happen here? They are going to be sharing like that. So two.
Okay,
Now
sir.
you count this one, this circle. Can you count in this circle here up to here? It's 2 to 4
Eight.
to 6 to 8. 8 electron. 8
Eight.
electron means octet. This is the called
Ah,
stable octet. It's stable octet. Okay. In this circle, if you see this circle, again that is going to be 8 electrons. So that will become again stable octet. And since two electrons here in this process, so that is going to be double covalent bond. Can you understand this?
fine, sir.
Double covalent bond. Okay.
So covalent bond only occurs between two same element.
Generally, non-metals, they are going to be found in the
Ah,
non-metal, may or may not be same. May or may not be same. I am telling you type of covalent bond. Third one,
okay,
suppose
okay.
if I will talk about nitrogen, what type of bond are you expecting in between?
Triple bond.
Triple. Why triple?
So because outermost has 7 electron.
Is it? If 7 electron means they can gain 1 electron, right? They
Uh-huh.
required 1 electron. 1 electron required means single bond now.
Sorry, sorry.
It
The
is, see,
five.
this is 2 comma 5. 5 means what? Required how many electron? 3 electron.
3.
Here another nitrogen is there, another nitrogen. So 2 comma 5. This is going to be required how many electron? 3 electron. Now you will find that is both are having the same power to attract each other. So they are not going to transfer any electron. They are going to share the electron. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now you see.
Hmm.
So now 6 to 8, 6 to 8.
Okay.
So what is 3 electrons shared? So that is triple
Triple
covalent
bond.
bond is going to be formed. Are you getting this?
Okay, okay. Sorry, sir.
Huh. Now let us move to the types of covalent bond. Types. Types of covalent bond. Covalent bond. Types of covalent bond. If you go on the types, the covalent bond is going to be two types. First one, polar covalent bond. Polar. Have you heard about polar covalent bond? Polar covalent bond. And second one is the non-polar covalent bond. Non-polar covalent bond. Non-polar covalent bond. Okay. Here is between, this is going to form between, B by W means between atoms of different electronegativity. Different
Hmm.
electronegativity. Electronegativity. This is just like you must have studied that is plus I effect, minus I effect. That is based on it.
Yes, sir.
Okay.
Okay, sir.
So example you can do. HF. This is polar covalent bond. HCl, polar covalent bond.
One should
H2O.
be less, one should be more electronegative, one should be less electronegative.
Yes. H2S. This is NH3. That is why they are soluble, little soluble in water. NH3. These all are the polar covalent bond. This is non-polar covalent bond between atoms of same electronegativity. Atoms of same electronegativity. Same electronegativity. Atoms of same electronegativity. What do you mean by same electronegativity? Means it can be H2, it can be O2, it can be N2, it can be
Same
Cl2.
metal.
Anything it can be same. Okay. Now,
Uh,
what is having the polar covalent bond? Means the shared paired electron moves towards the what? Electronegative atom. Are you
Most
getting?
electronegative atom.
Yes. So more electronegative. That is what is called the covalent bond formed between atoms of two different electronegativity. Electronegative atom are called polar covalent bond. Right. In this type of
Yes,
bond,
sir.
the shared pair electron shift towards the electronegative atom. Are you getting this?
What is this one, sir?
What?
This one.
H. This one H2S actually. I was supposed
H2,
to write
yes, sir. Okay, okay.
H2S. This is NH3.
Okay, sir.
Okay. So if suppose you want to have the explanation now, fair explanation. So suppose it is the HF you can take HF. So
Hmm.
hydrogen is 1. So this is 1. Fluorine is
Okay.
9, 2 comma 7. 7 is more electronegative na. This is having the plus 9 proton. So what they are going to give? HF, they are going all, of course they are going to share the electron. But here the electron of hydrogen is very close to the fluorine, very close to the fluorine. 2 to 4,
Hmm.
very close to fluorine. So what will happen, wherever the more electron density is there na, that will acquire the
Ah,
negative charge. So this will be partially negative, this will be partially positive. So here whenever
positive.
we are writing the HF na, so we write partial negative, partial positive, because electron
Hmm.
are shifted towards what, this one. Are you
Fluorine.
getting? Yes,
Ah,
that is what is polar covalent bond. Partial polarity developing now, positive, negative. That is what is called polar covalent bond.
okay, sir.
A non-polar, so already you know, na?
Ah,
Okay. Let us have a look over uh, the same time you understand the hydrogen bonding. Okay.
okay, okay, sir.
Because it is related to hydrogen bonding. Okay, hydrogen bonding. Here, this is important one. How it is defined? The force of attraction, force of attraction between, force of attraction between mm, hydrogen atom of hydrogen atom of most elect hydrogen atom of one molecule, hydrogen atom of one molecule
Hydrogen
with
atom of one more.
with most electronegative. It is intermolecular hydrogen bonding, na? This is the not atomic bonding. With
Hmm.
most electronegative, electronegative atom of another molecule, another molecule. So see, if suppose you are taking HF, which atom form actually? Which atom? The hydrogen. See, here is the star one. The hydrogen attached with attached with attached with nitrogen, oxygen, and fluorine can formed can only formed can only
Hmm.
formed hydrogen bonding can only form hydrogen bonding. No other element. If hydrogen is attached with any other element other than nitrogen,
Ah,
oxygen, fluorine, they are not going to form the hydrogen bonding. Right.
okay,
Now,
sir.
suppose example, you see the HF. HF can form. How? There is the polar covalent bond now. This is
Ah,
negative, this is a positive. You take the another one, HF. Negative, this is positive. You can take one more, HF. They are the molecule. Okay, they are not the atoms. Now, you see what is happening. Opposite charge in the chemistry get attracted to each other, right? So what
ah,
is going to happen here? What the definition is there? If suppose you consider this is first, so it is going to be second. So they are saying force of attraction between hydrogen atom
green.
of one molecule. This is the hydrogen atom of one molecule with, they are saying, with most electronegative atom of another molecule. The fluorine is most electronegative atom of another molecule. So this
Okay.
is the bond is what? H bonding. This is H bonding. Can you understand this?
Yes, sir.
Hmm. This is the hydrogen bonding.
Hydrogen bond.
I'm erasing now.
Yes, sir.
Okay. See, suppose you are going the H2O, right? So HOH, then again HOH, then again HOH, HOH. So you will find this is negative, this is the partially double positive, this is, oh, sorry, yeah, this is the
Sir,
negative. Ah,
hydrogen.
what happened? Is it not okay?
It's okay, sir. Now okay.
Uh, this one. Why I am putting the double negative on the oxygen atom? What can be the reason? Okay. So that is suppose you are taking this one first molecule, then it is going to be second. The force of attraction between hydrogen atom of one molecule with the most electronegative atom of another molecule. Similarly, this is. So these all are the hydrogen bonding. That is why H2O is found in the liquid state. Question is there. H2O is found in liquid state. Found in liquid. But H2S is gas. But H2S is gas. Why? Can you explain? Same
Due
one.
to
Same one more question is there. Second one. HF is liquid. HF is liquid. But HCl is gas. Third one. Huh. Third one.
all three same answer, sir.
All are the same answer. NH3 is liquid. NH3 is liquid. NH3 is liquid. But pH3 is not. What can be the answer? Can you tell me?
Because they are able to form hydrogen bond in water.
Why they are able to form the hydrogen bonding?
Also, one electronegative atom is attached to hydrogen.
Because hydrogen is attached with the most electronegative atom, that is
Oxygen.
nitrogen, oxygen, fluorine. Okay, this one.
Ah,
Okay, some more question. Let us look over this. The questions are very simple. Let us have a look over it. HF, HCl, NH3 are soluble in water. Are soluble in water. Soluble in water. H2O. But CH4, CH4, you can write C2H6, C6H6 are not soluble. Are not soluble in water. What is the reason?
they are able to form hydrogen bond in water, but CH4, they are not able to form.
These molecules are able to form hydrogen bond with the water molecule.
What
How they can
molecule?
form the hydrogen bond with the water molecule? If you see, let us have a
Yes,
look.
sir.
One second, let me erase. So you see, this is the HF is there now, HF. This is there.
Hmm.
Then you can write HOH. HOH. This is the positive, this is negative, this is positive, this is negative, this is positive. What will happen? That is the force of attraction
FM.
between hydrogen atom of one molecule with most electronegative atom of another molecule. That is H bond. Since it is
Ah,
able to form H bond, so that is what is going to be soluble in water. Soluble in
ah,
water. Are you be able to understand this?
yes, sir.
Okay. Let us have a look over it. Types of H bond. Types of H bond. Types of H bond. What have you heard about this one? Types of H bond.
Yes, sir. Intramolecular hydrogen
Oh,
bonding.
great. Intermolecular H bonding. H bonding. And this is intramolecular. This is the intramolecular H bonding. Okay. What do you mean by inter? Have you heard about the international? International means what? Between two different countries. Yes or no?
Yes,
International
sir.
is between two different country. Means this bond is found means between two different molecule. Between two different molecule. Between two different molecule. Between two different molecule. Intra molecule. Have you heard about intranational? Intranational.
Yes.
INT. What is this? See, many airport are there
Same.
now in our country, like Chennai Airport.
Mhm.
So Chennai Airport is international, means that is what? International flights are there. If you go like Salem Airport is there now. That is purely domestic, no international flight is there. So
Mm.
So that is what between the cities they are flights are available now. So in the
Nice,
same
sir.
country that is called intra. Same country means
Hmm.
intra. So what is the between same molecule? H bond. What we will write? H bond in same molecule. H bond in same molecule. H bond in same molecule. Right, same molecule. But here is H bond. If you talk about H bond in between two different molecule, right? Suppose I am writing HF. So one molecule, again HF you are writing HF. So these two different molecule, na, two mole of molecule. Or you can write
Hmm.
HF and you can write that is H2O. This is again going to be, so here this bond are the intra. And but here you see, have you heard about benzaldehyde?
So inter, no.
This is inter, yes.
Ah.
Here you see OH. Here is, suppose C double bond O, here is H. So what type of bond is between the same, na? Only one molecule is there, na? So this bond is the
Hmm.
same molecule. That is what is called intramolecular. Intramolecular. Understood?
Ah, okay, sir.
Hmm. Here somewhere it is there, screenshot is there. If you want the PDF now,
So,
you
sir,
huh,
between HF and HF,
huh. So two
or
molecule
between,
is there now. Different means what? Different means what? It can two molecule number. Different means what? Number. It is related to number.
hmm.
Two different molecule. It is not like that. You can say HF and HF both are the same molecule. In the number, in the number
Ah, okay,
two. Getting my
okay,
point.
okay.
Here the number is how
Ah,
many? Number equal to one. Right? Here the number it can be two, it can be more. Between two different molecules means they are the HF and HF are the different entities. And here
ah,
also this bond is also possible. NH3 and H2O. This is also two different, one molecule, one molecule. Here is one molecule, one between. I don't know how can you
hmm.
understand.
Ah,
But
no,
I'll
no, no, I get it, sir.
okay, great.
You asked doubt whether.
No problem. Acha. Another point which we are supposed to explain. Question I'm giving. Which one is
Ah,
more volatile? Which one is more volatile? More volatile. Which one is more volatile? Orthonitrophenol or paranitrophenol?
orthonitrophenol.
Why?
Because of intermolecular hydrogen bonding.
Orthonitrophenol, na, not inter. This is going to be
Oh,
intra.
ah,
Intra means what? Only one molecule will be there, na. Only one molecule.
ah.
So only one molecule means there is no association. So no association means what? It is
That's a
going
steam
to,
volatile.
yes, it is going to exist as alone. So this is called intra. But paranitrophenol, na, they will form the so many bonds. Suppose it is OH is there. Here is N double bond O, coordinate bond O. Then again another molecule is possible. O, then here is H, then here is the ring, then here is going to be NO2. So here is the big molecule, na, big molecule, and that is what
Yes, sir.
Van der Waals forces. Have you heard about the Van der Waals forces?
Yes,
Van
sir.
VAN, Van der Waals forces, proportional to
Ah,
size, proportional to size or molecular mass. So in which case molecular mass is more? This case where association is there, na, many molecule. With a
mm-hmm.
large number. So here the interaction is more. So more interaction means more boiling point. More boiling means by less volatile. This is what? Less volatile.
Nice, sir.
Less volatile means less vapor pressure.
Ah,
VLATILE. Okay, understood.
yes, sir.
Okay, this was the hydrogen bonding. Now the covalent bond is over. Now let us go for the coordinate bond. Coordinate bond. Tell me, what do you mean by coordinate bond? Have you heard about this?
Yes, so
What you heard?
only one electron is being shared.
Oh, no, no, never. One electron share, then how can a bond is will form? Is it possible to form bond? Paired required na? Paired. Two electron can form the bond. One electron impossible.
No, so one electron is being shared.
Sharing, see, if I am sharing something now, so how can possible only one way? Suppose one is sharing only one thing. Not possible, na?
Oh, this is dative bond.
Yeah, dative word. Coordinates mean dative. Yeah, correct. Uh,
Oh, okay, sorry.
uh. Coordinate means
Then,
dative. Okay. Now, so what is the definition? Did you remember that one?
yes, sir, that within the coordination and sphere, that only no.
Uh-huh. Okay, no problem. The covalent bond, they are the covalent only. The bond
Uh,
formed
Between
by
central metal ion and
Mhm.
ligand.
The bond formed by that you can say
Bond.
that you can say sharing of lone pair electron, sharing of lone pair electron by only one atom, by only one atom.
That's only, sir, I meant. Only
Yeah, correct
one
only.
will
Correct,
share.
correct.
Ah,
It's called coordinate bond. It's called coordinate bond. Coordinate bond. Okay. Suppose example if I am writing H2O2. Okay. NH4 plus. Okay. H3O plus. They all are having the dative bond 1 1. Otherwise, you can go any coordination compound. That will be the this bond only. So suppose where what I wrote here. H2 no H3O plus NH4 plus see H2O2 H2O2 not H2O H2O2 I am explaining the H2O2. Suppose hydrogen is there, oxygen is there. Hydrogen one electron. How many valence electron there with the oxygen?
two, sir.
Valence electron 2. Oxygen
How much?
atomic number 8. So configuration
8,
2 comma 6. How many valence electron?
6, sir.
6. So valence electron participate in chemical bond. 1, 2, 3, 4, 5, 6. Right.
Will participate. No?
Uh-huh. So how all will
One
not
there.
participate. It will be depending now how for octet how many electron required. So here
Ah,
they are able to form the octet. Yes, yeah, no. This is
ah.
8 electron. This is the 2 electron. But one more oxygen is there. Hydrogen peroxide. One more oxygen. 1, 2, 3, 4, 5, 6. So its octet is not complete, but here the octet is complete. This oxygen, first oxygen complete. Then what? How the molecule can be stable? So what is happening? This one, this two electron of only one oxygen atom is there shared. This oxygen atom is not sharing electron, but it is taking two electron. Are you getting this?
Ah, yes,
Now,
sir.
now how it is forming? Single electron shared, one electron. So pure covalent bond. Here two electrons shared like that. So that is called, this is called coordinate bond.
Hmm.
Coordinate bond. Can you understand this?
Yes, sir.
Hmm. Are you writing or what?
I'm writing.
How fast can you
Sir,
write this one?
no. Sir, seriously, I'm writing, sir.
Immediately I'm erasing. So is there problem or what?
Now, as you're telling, I'm writing.
Okay, good. Then you can ask me to go little slow. We'll go.
No, sir, I wrote.
Okay, great. Now, suppose I am explaining one more. Suppose you are going NH4 plus. NH4 plus means what? Do you know? NH3 plus H plus. Right, proton. Here is lone
Sir,
pair
they
electron is
always
there.
have positive charge, coordinate bond.
Uh-huh. So this is the NH4 plus. This one, NH4 plus. Now, how to explain this NH4 plus? So nitrogen you see 7 2 comma 5. How many hydrogen are there? Three hydrogen. Here is one electron. Here is one electron. Here is one electron. H plus, if you are going, this is going to be how many electron? Zero electron. Yes or no?
Yes, sir.
So nitrogen, if you see, hydrogen,
So NH3, two lone pairs, sir.
one lone pair. Lone pair means what?
One lone pair.
Lone pair means two electron. No, pair means two electron. So here is hydrogen, hydrogen, hydrogen. So you see
Three.
one, two, three, four, five. Five electron, five valence electron, na?
Yes, sir. Yes, sir.
Okay. Now H plus is having no electron. Here is they are having the electron. They are having the electron here. So they are going to form the duplet. There is no problem in this duplet. This is duplet. Now, it is also, if you see, this one you see, this one completed octet. Can you understand?
Yes, sir.
Okay. And they completed the duplet, right? Yes or no? Now, you
But H
see,
plus.
uh, H plus is having zero electron, but here it completed octet. Now, it does not require. So, what is happening? This H plus is sharing this electron of nitrogen. Now it completed duplet, but both the electron, in this case, both electron is off. Both electron is of what? Nitrogen, na?
Yes, sir.
So coordinate bond. So what we can write? So
So only
coordinate.
one is. Uh,
So here you see, this is the nitrogen. Here is coordinate bond O, hydrogen, sorry. This is hydrogen plus H plus. Remaining are the pure covalent bond. There is no problem. Can you understand this?
yes, sir.
Hmm. So this one is there. Ionic bond, do you know ionic bond?
Yes, sir.
What is ionic bond?
Between metals.
Hmm. Between metals and non-metals. Ionic
Uh,
bond. Ionic bond. Ionic bond. Okay. So
Between opposite charges.
hmm. formed by formed by formed by transfer of what the point? Formed by transfer of electrons from metals to non-metal, from metals to non-metals, formed by transfer of electron from metals to non-metal.
Non-metal.
Okay, so this is going to be what? This is going to be ionic bond. Are you getting this?
Yes, sir.
So example, if you see NaCl, okay, or you can say KCl, or you can say MgO, or you can say MgCl2. Okay, these all are the, or you can say even many example you can give. There is no problem here. Okay, so here you see NaCl. So Na configuration is what is 281. Atomic number is 11. Cl configuration is what is 287. So what is there?
Ah,
To read this one properly, one electron is extra. One electron is extra. So if you want to be stable, it need to remove one electron. And one
yes.
electron is less. One electron is less.
Gain one
So
electron.
it required to gain anyhow one electron. So any number
Ah,
of dot equal to number of valence electron. That is very simple. Number of dot equal to number of valence electron. So here 1, 2, 3, 4, 5, 6, 7. So here configuration is 281, one is extra, 287, one is less. So what is going to happen? This is going to transfer, complete transfer. Since it is transferring completely, that is why it is called ionic. In the polar covalent bond, they were not transferring completely. Formed by
yes, sir.
you can use the word complete transfer of electron. So it is the one electron completely transferred. So Na plus, not partial, fully plus, and Cl
Ah,
minus. So here
minus.
now one electron lost. So two configure 2 8. Here is 2 8 8. So what is pure covalent, pure ionic bond? This is the ionic bond. Can't you understand this ionic bond?
Yes, understood.
You can represent like this one also, Na plus and Cl. This is the 1, 2, 3, 4, 5, 6, 7, 8. This is here the valence electron become the, that is after losing, we write like this. This is the expression of ionic bond. Right? Plus minus is there, na, they are going to attack. The attraction between positive and negative charge is called ionic bond.
Okay, sir.
Okay. What else? This is ionic bond. Now let us have rule. Fajan rule. Fajan rule. This rule is given to explain explain ionic character ionic character ionic character in covalent bond, right? So here what
Yes,
they,
sir.
larger the size of larger the size of larger the size of what? Larger the size of, mm,
Cation.
if you see cation, larger the size of cation, not the cation is not the, oh, cation is not the, what they actually means now, the electron, suppose this is the atom A and atom B. Suppose you are positive, negative. So you are going
Ah,
to explain the ionic character. Okay. So ionic means the electron should be not between.
okay,
Electron should
sir.
not be exactly between. Electron here it should not be exactly between two. Other if between exactly between two, now this will be covalent. So either
Ah,
the electron should come here or electron should go there. Any possibility. So larger the size of cation. Suppose cation size is more. Okay. So it cannot attract the electron easily. It is donating the electron. Yes or no? So more the electron
ah,
will be going here. So larger the size of cation, greater, greater the ionic character. Otherwise, you use the two word, larger the size of cation and smaller the size of anion. Smaller the size of anion. Size of anion. So more will be ionic character. More will be ionic character. Ionic character. Like
okay,
LiCl,
sir.
NaCl, KCl, RbCl, and CSCl. So which one is most ionic? Supposed to be most ionic. Which will donate? The CS will donate mostly electron, na? Yes or no?
Yes, sir.
So the ionic will be here. This is the ionic, purely ionic. Okay. And this will be covalent. Covalent. So if you are moving down the group, ionic character increases. Why?
Ah,
Uh, Ionic character increases. Can you understand this?
okay, sir.
Okay. So this is
Lithium,
the
sodium, potassium.
only one example I have given. Now it is the for
Sir, one second.
no problem. It is automatically going to disconnect because 40 minutes over now. So
Sir, can you send in this itself, sir?
what?
In your laptop itself, can you send the link?
But laptop if I am sharing,
Ah,
this is not going to work now.
it's
We cannot join again. It will take